Good day, my name is CHIA JAN FENG, metric number A179702. Now, I am going to present the simulink assignment using simulink MATLAB. In this control system for CSTR using simulink MATLAB, first, you have the set point with value of 60, and also the PID controller. Please note that this is the manual PID controller with the P value, I value, and also the D value. We also have the disturbance currently unconnected, the process. Inside the subsystem process, we have the transfer function for energy balance jacket, transfer function for energy balance CSTR, and also mass balance for CSTR. After the process, we have the measuring element, and also the response curve inside this box. Besides that, we also have the figure of merits using ISE, IAE, and ITA method. Now we are going to run the simulink. So this is the curve without disturbance. Now let's connect the curve. As you can see with the disturbance, the curve overshoot a bit. Now we want to compare the manual PID controller with the two-box PID controller. So everything is the same, the value is the same, the set point, and also the disturbance, the transfer function, all are the same, except now we are using the two-box PID controller. Now we run the simulink. So this is the response curve. Now we want to compare the P, PI, and PID method. So in P method, I and D are 0. In PI, only the D is 0. In PID, all the values are inserted. So now let's run the simulink. So using our naked eyes, we can actually see that the green line, the green curve, has the lowest overshoot, which is the PID. So using our naked eyes, we can see that the PID is the best. But we also have a more accurate method, which is using the ISE, IAE, and ITA method. The controller with the lowest values are the best. So proceed. We also want to see the effect of multiple inputs and multiple disturbance. So in the first set point, we have step type of 1 with final value of 20. Second, step type of 15 with final value of 30. Third, step type of 30 with final value of 10. So in the disturbance, first, we have the step type of 1 with value of 2.5. Second, step type of 15 with value of 5. Third, step type of 30 with value of 12.5. So the PID controller and all the parameter settings are the same. Now let's run. So this is the response curve and set point for the multiple inputs and outputs. So the same, we also want to compare the multiple inputs and outputs using P, PI, and PID controller. So now let's run the simulink. So this is the response curve. After see all the response curve, we want to now check the tuning method. First is the Ziegler-Nichols method. So in this method, first we want to find the best KC value. So I already tried all the trial and error. So the value is 1.8865. So I already done the tuning. So the period is 2.951. So I already set the first point and second point. And now let's insert all the values in the MATLAB. So the KCO just now we see is 1.865. The period is 2.951. Now let's run the MATLAB. So we got the values. So now let's insert the values. So the KC is 1.1319. The integrator tau I is 1.4755. The tau D is 0.3688. Yeah. So the formula can be found in the book. So now let's run. Sorry. As we can see, using the Ziegler-Nichols method, the response curve actually converges to the point. So we show that the tuning method is successful. Now proceed to the Cohen and Cohen method. In this method, we separate the PID controller with the load, and we also have the M with the value of 2. So now let's run. So I already set, and then I found the gradient. So in the first point, the value is 1.022. The gradient is 2.337. So now let's insert those values inside the MATLAB. So I already done the formula. This formula can be found in books. So the BU, we can see that the curve converges to the value of negative 11.5. So here is negative 11.5. The S is the gradient. Gradient is 2.337. The M just now we set is 2. The first point is 1.0222. So now let's run. So we got the value of Kc, tau I, and tau D. Now let's insert those values. So as you can see, I already insert the values beforehand. So the P is 1.073. Here, 1.073. The tau I is 2.772. So 1 over 2.772. And the derivative is 0.3x622. And here we want to compare the tuning method, the Cohen and Cohen, Ziegler and Nichols. So these are the values we found just now. And also the one without tuning using the PID controller. Now let's see the result. As you can see, all three tuning method and also the without tuning method converge to the value of 60, which show they are successful. But to see whether or not, to see which one is the best, we will refer to the SE, IAE, and ITAE method. After that, we will see the cascade control. Inside the cascade control, we separate the subsystem into two parts, the inner loop and outer loop. So in the inner loop, we have the mass balance CSTR, energy balance CSTR, their transfer function. In the outer loop, we have the energy balance for the cooling jacket. These are the transfer function. So we have two PID controller. In the first one, we use the O parameters. And second one, the parameters are found using trial and error method shown here. Now let's run the simulink. And this is the result. Actually, it's successful because it converges to the point. I think that is it. Thank you.